So this is the video going over the Chapter 8 free response in the review packet. Okay, so number 1 was basically an SPDC problem for a one sample proportion. I read through all that and figured out, kind of what was what. 200 is your sample size, and your p hat is 16 out of 200, which is 0.08. Now, the phrase that tells you that you have to do the whole SPDC thing is this: construct and interpret. And if you take that literally, you think, oh, I just need to get the correct interval and then write my interpretation sentence. But that is not enough. They need the full procedure. So you need to know that that phrase, construct and interpret, means the whole 4-step process. Okay, and then as always, they will give you the percent, 95%. All right, so what I'm going to do is I'm going to go through the solution, and then at the end, we'll go through and talk about how they would have scored it. So part A, and it's in a slightly different order than what we do in our SPDC, but all the things are still there. And they actually didn't grade every little piece of it, but nearly all of them are there. Anyway, so notice that they were looking for the name of the procedure. And so they actually allow the name in words, or it sounds like they allow the equation. Either way, they give you points for that. Best to have both. I normally have you do both. And then they also define the parameter here, the true proportion to defective components. And then they wanted you to check your conditions. So random sample, that was in the original problem. And then they actually don't have you check the 10% condition. It's still good to, but it looks like for whatever reason, they didn't grade on that. They must have felt like it was, the truth is they're also trying to they know that different AP Stats classes around the country are all using different textbooks. Ours is the most common, but they try to not grade you down if you happen to be using a different textbook. So maybe our textbook makes a bigger deal of the 10% rule. I don't know. So regardless, they didn't grade for that, even though it's still good to have it in there. They did grade for the large counts, though. So they said number of successes, which is n p hat, number of failures, which is n 1 minus p hat, need to be both greater than 10. And then they say or 5 or 15, because again, they're trying to make this work with no matter what textbook you use. Our textbook says 10 is the cutoff. Other ones say 5 or 15. It still hits the same big idea that you need to have a large enough sample size. And so different textbooks differ on what's considered enough, large enough. But anyway, that's why they have other options, because different students are using different textbooks. So anyway, you do the whole NP and 1 minus P thing, and you get 16 and 184. And they are all bigger than 10. So we're good. Okay, so that's what you do for conditions. Then comes the do part, and they do want you to show your work and then give your actual answer. And then interpret, well, you recognize this. We are 95% confident, and they put their context and parameter first and then their interval at the end, but same stuff is in there. You need the 95% confident. You need the true percentage of defective components in the batch. So the parameter needs to be in there, what it is you're trying to estimate, and then your actual interval. Okay. Now for part B, they said, can you narrow it down between grade A, B, and C? So remember that grade A was 2%. B was, I don't remember now, 5 and 10. I guess I did have that there. So B was 5% and C was 10%. Well, we found from our interval up here that those are our plausible values. Those are the values that we're saying are reasonable to happen. So we think all the plausible values are between 4.24% and 11.76%. 2% is not in there, but 5 and 10 are in that interval. So this has been enough information to eliminate grade A. We know it is not grade A, but it could be B, it could be C. Either one of those is plausible based on the sample that we got. Okay, so scoring wise, if we go down, they kind of broke it up into pieces. So they needed the name, said either by name or formula. And they need the condition of random sampling stated and checked, and the sample size condition stated and checked. So that's the large counts. So that's what they were looking for in kind of that first chunk. Then in the second chunk is about if the interval was correctly computed. And they do give you some partial credit if you make some specific steps, which granted, they won't know that you did that unless you show your work. Section 3 is about the interpretation. So they need context in there. They need to be talking about defective parts in a batch. They need to talk about what the parameter is. We've been calling it the true proportion. Here they're saying the proportion of all defectives. And 95% confident needs to be in that phrase. And then section 4 was about that last piece. Can you make a decision? So basically saying that you cannot decide between B and C because they're both plausible, but A can be ruled out based on the interval. Okay, so that is question 1. And then for, like it always does, it repeated all of it. So then scan through, I think, to page 8 or 9 for the next one. Okay, on to number 2. So with this is a 2 sample situation. So I went ahead and found my these are P hats. And they don't say construct and interpret, but they still want you to do SPDC. So on a free response question, I will say on my tests in this class, I will make it clear. I will actually say SPDC on there. On the real AP test, if they ask you to do a confidence interval in a free response question, you should do the whole thing. There's no way they're asking you to do it without asking for all the pieces of it. Okay, so, and then on a side note, they also say for B, based on the confidence interval, do you think the difference in proportions is significantly different from 0? So they're asking you, is 0 a plausible number? But we'll get to that in a second. Okay, so again, I'll go through the solution and then I'll kind of point out what they cared about for points. So they wanted the procedure name, and it looks like they were okay with the name or the equation, as long as it's all variables and stuff. Again, better to have both. And then they wanted the parameter in there, what it is that you're actually estimating. For the conditions, again, they didn't do the 10% thing, but they did do independent random samples, and they did the large sample. So this one, that we've been calling it large counts. Okay, now it's interesting when they look at this, they said, oh, it's not down until grading. I'll just tell you. So they said that they were okay with you not having the word random in there, but they did want you to talk about independence. Like that they're not just random samples, but independent random samples. So somehow describing how you know that. Like in this case, they say different employees work the 2 different shifts. So it's not like how one did on the day shift should affect anything about the night shift because they're different employees. And then later on in the grading, they even said if you just had the word independent with a check next to it, they would call that good. That means that you knew you were looking for independence. So they were looking for independence. And then the large counts thing. So if you do the full equations, you get 188, 180, 12, and 20, which honestly you kind of knew because they gave you the counts in the beginning. It really is, these NPs are the number of successes in your sample, and the 1 minus P's are the number of failures in your sample. So they did kind of give them ahead of time, or just do the equations. Okay, then they needed correct mechanics. So all the do part, plugging in the right numbers in the right order and calculating it correctly. And this is the interval you should be getting. And again, a little bit of rounding error is fine. Show your work. And then for interpret, so 96% confident that the difference, the proportions of parts meeting specifications for the 2 shifts, there's your context, and there's your interval. And then for part B, 0 is in this interval. It starts negative and ends positive. So if you imagine this interval on a number line, it does include 0. So that means 0 is plausible. It is plausible that there is no difference between the day shift and the night shift. Therefore, this confidence interval we do not have evidence It is not good evidence to say there's no difference because it is saying 0 is one of the plausible values. So not good evidence to say that's not 0. Okay, so I'm just going to go down to the scoring a little bit. I already talked about that. Okay, so this is worth saying that to get it essentially correct, so completely correct, you do need to include a statement indicating that the data doesn't support beliefs. It says it is incorrect if the student says no because 0 is in the confidence interval, or just says no without providing relevant justification. So you can't just be a minimalist and say 0 is in the confidence interval, not evidence. You have to explain why that is. Explain why 0 is, what that means. It means there's no difference between the shifts and that's plausible. And so you have to explain it. You can't just say 0, no. Okay, I think that's it. All right. And ignore the rest of the worksheet. It's just a repeat.